Hi again everyone, this is the fourth lesson on our recurrence relation topic, and today we are going to look at limits. First of all, I'm going to show you a couple of different recurrence relations, and we're going to look at what happens if we keep generating terms. So if we look at this first recurrence relation here, un plus 1 equals 2un plus 6 with u0 equal to 2. The first three terms are 2, 10, 26. You can put that recurrence relation into your calculator and keep generating terms. The next one comes out as 58. The next one after that is 122. After that, 250. And if you keep generating them, you will see that they keep increasing and they keep getting really much bigger. So because these keep increasing so much, we say that this sequence is said to be divergent. If we look at the next recurrence relation here, we've got un plus 1 equals 0.5 un plus 2 with u0 equal to 20. And if we look at what happens to the terms of this sequence, well, the first three terms are 20, 12, 8. After that, if I generate the next term on my calculator, it's 6. After that, 5, and if I keep going, I end up with 4.5 and so on, 4.25, 4.125. We can see that it is getting closer and closer together. Because the terms are getting closer and closer together, we say that this sequence is convergent. And basically this sequence will reach what we call a limit. So eventually a convergent sequence will reach a limit, and the sequence generated by un plus 1 equals aun plus b will have a limit if and only if your value of a is strictly in between 1 and -1. So this thing here is key. If your value of a is in between 1 and -1, your sequence will reach a limit. So you can see for our first sequence, our value of a was 2, so it didn't have a limit. But for our second sequence, our value of a was 0.5, so it would have a limit. So what we're going to do is we're going to look at calculating limits. So in fact, we're going to do a wee example before we calculate limits. So which of the two recurrence relations listed below has a limit? The first one, un plus 1 equals 3un plus 1 with u0 equal to 6. Now I can see straight away that my value of a is equal to 3, and that tells me here that this sequence will not have a limit. So this one will not have a limit, as a is not in between 1 and -1. The second sequence, though, we can see that the value of a is equal to 0.3, and this one will have a limit. And the justification for this is that our value of a is in between 1 and -1. We can see that 0.3 is in between 1 and -1, so this one has a limit. Okay, what we're going to do now is look at calculating limits. So as well as identifying whether a sequence generated by a recurrence relation will have a limit, you can find its limit. There's a couple of different ways to do this, but we're just going to show you one way at the moment. And it's pretty straightforward. The formula to find the limit L is given by L is equal to b over 1 minus a. So we're going to use that to help us. So the example on the left hand side, find the limit of the sequence generated by the recurrence relation un plus 1 equals 0.2 un minus 4 with u0 equal to 2 as n tends to infinity. This n tends to infinity, don't worry about that. It just basically means as n's getting larger and larger, i.e. we're generating more and more terms of our sequence. The first thing I'm going to do, and I always do this regardless of the question, is write down the limit condition. And if you're in my class, you will know that I use what I call star statements. So I'm just going to write down that a limit exists for this sequence as 0.2 is in between 1 and -1. I always write down these key statements because depending on the question that you've got, you may pick up a mark for it. So I always just write them down, and my class call them star statements. So that's the first thing I'm going to do, write that down. Next thing I'm going to do is write down the limit formula. So L is equal to B over 1 minus A. So in this instance, B is negative 4. So I've got negative 4 over 1 minus A, so it's 1 minus 0.2. So negative 4 over 0.8. Now quite often you can get questions like this in a non-calculator exam, and people tend to get a wee bit stressed when they're dividing by decimals, and they tend to lose marks for this. And there's a simple thing you can do to make this calculation a lot easier. So we've got the limit is equal to negative 4 divided by 0.8. If we make an equivalent fraction here, it makes life so much easier. So if we multiply this by 10 to get it as a whole number on the bottom, and obviously we have to multiply by 10 on the top to make it an equivalent fraction, it just makes your calculation so much easier. We end up with negative 40 divided by 8, which obviously comes out as negative 5. So the limit of that sequence is negative 5. If you punch this recurrence relation into your calculator, un plus 1 equals 0.2 un minus 4, with u0 as 2, and keep generating successive terms, you will find that they eventually go to negative 5. Now if it's asking you to find the limit of a recurrence relation, you must use the limit formula. It is not acceptable to continue to generate successive terms, so you've got to use this formula here. What I'm going to ask you to do is pause the video and attempt the question on the right hand side. Okay folks, hopefully you've had a go at the question on the right hand side. We'll have a look at it together and just make sure that you managed to get it. So find the limit of the sequence generated by the recurrence relation un plus 1 equals 0.9 un plus 3, with u0 as 5 as n tends to infinity. So again, I'm going to write down my star statement that a limit exists as 0.9 is in between 1 and negative 1. So I always write that down. Then my limit formula, L equals B over 1 minus A. So this time B is 3, so it's going to be 3 over 1 minus 0.9. So L equals 3 over 0.1. So again, imagine you're doing this without a calculator. Make an equivalent fraction here, multiply the top and bottom by 10, so you get 30 over 1, which comes out as 30. So the limit of that sequence is 30.